Guys, when it comes to thermodynamics, we are not concerned with what energy looks like, but rather our important question over here is, and all the theorem and all the discussion deals with this question, how energy crosses the boundary of a system. I'm writing it very slow and trying to write it as neat as possible because this is important. The entire idea deals with this. Say I consider this chamber and this piston and everything as the system, and obviously this is our surrounding. The question is, how will the energy get into the system? How will the energy come out of the system? Here the answer is heat and work. So that's our answer. So the entire idea surrounds these two terms, heat and work. Okay guys, so how will energy come into the system? How will energy go out of the system? It is in the form of heat and work. So all the discussion that we're going to have are dependent on these two works. That's why I have a separate video talking about it in terms of thermodynamics, right? So heat is energy transferred because of temperature difference between system and the surrounding. Okay, so this you have already seen the definition. There's no change over here. Work is the one which is a bit new to you guys over here. So heat always flows from hotter region to the cooler region. A system does not contain heat. It only receives or loses heat. Again, you need to understand that it's not an internal property of the material per se. While work in thermodynamics happens, the two keywords over here is, so when it comes to work, the two key words over here is expansion and compression. So in thermodynamics, the work is again, it's exclusive to thermodynamics. Work is said to be done on the system or by the system and all of that with respect to these terms. Either you are looking at the system to be either compressed or expanding. So compression and expansion are the key ideas behind the work when it comes to thermodynamics. No other form, this is the form. That has to be very clear. Work is done when we have energy transfer in the form of system's boundary movement. That is either expansion or compression. So basically when we're looking at a piston, what happens? Piston goes up and down, right? And that's how the entire thing works. So this is a crude diagram of a engine. And yeah, this is, anyways, things are not exactly right, but you get the idea. So you can imagine the movement of the piston, and the piston is doing work, and all of this engine is basically born out of thermodynamics. So you can understand that the work over here is to do with, and the nature of work is to do with compression and expansion. Right? And we have a small important note. Heat and work are not the properties of the system per se. It is not stored in the system. It is only transferred across the boundary. While the internal energy is part of the system, unlike your heat and work. Sign convention, I have repeated quite some time, but I do want to talk about it again. When you have Q to be positive, work to be positive, it has a particular meaning. Q is positive, heat is added to the system, so system will gain energy. When work is negative, systems gain energy. So this has to be very clear. And obviously there is loss over here, and this is also loss. So be very clear and keep this table in mind. I'll start using this again and again so that, because people get confused over here. Many people think W being positive means system is gaining energy. No, it's not. So here heat, when it's positive, it's system gains energy. So gain is to do with system. Okay, all this is with respect to, or let me write it here, with respect to system. This table is important. because in time you guys will forget. Even I forget. If not for this table, I forget. I know that it's cross, so I know that it's not one down the other, it is cross. So that's how I remember it, making it easy for me. That's it. Okay, so yeah, if you guys want to start with this, you can.